When we move into solving equations with applications, the general strategy that we just established still holds. We follow all of those same steps. The only change is going to be that now we have a word problem again, and we have to infer from that problem, we have to translate out of that problem what equation it is that we need to solve. In example 4, we have that Sylvie bought markers and colored pencils at an art supply store. The number of markers was 6 more than twice the number of colored pencils, and we're told that she bought 27 markers, which I'm going to go ahead and fix. That should actually be 28. So we know that she bought 28 markers. That's a value that we're given. And in this previous sentence, we're told that the number of markers was something, or is something. Those are some key words that we want to look out for. That's telling us that there's an equal sign there. So if the number of markers is, or the number of markers was, that means we want to say that number of markers, 28, equals, the next statement is 6 more than. So more than would be addition, so 6 plus twice the number of colored pencils. So twice means 2 times. The number of colored pencils, that's the unknown that we don't know, so we'll substitute in an x for that unknown value. Now in part B, we want to find how many colored pencils she bought. That means we want to solve this equation that we just generated. So to solve 28 equals 6 plus 2x, the first thing we'll do is subtract 6 from both sides, which will give us 22 is equal to 2x. We'll identify that coefficient for the variable term and multiply both sides by its reciprocal, which will give us 11 is equal to x. So this tells us that she purchased 11 colored pencils. That's what x represented in this case. The unknown number was how many colored pencils she purchased. Just like we did with the previous problems, we can check this result by evaluating 6 plus 2 times 11, which will give us 6 plus 22, or 28. So with that solution of x equals 11, our solution checks out with that equation, and we know we've got the right answer. In example 5, Franklin purchased a car for $35,753.50, including all his taxes and fees. The amount he paid for this car is $320.51 less than twice the amount he paid for his last car. So a real trick to these again is going to be translating that information into the equation that we want to solve. In this case, we're given the purchase price for that new car, and in the next statement we're told the amount he paid for this car is, so again that's that key word letting us know where that equal sign pops in. So this will be 35,753.5 equals $320.51 less than. So less than means we're getting smaller, we're subtracting. So we're actually going to leave a little bit of a space, and we're going to subtract that $320.51 and fill in that missing piece with twice the amount he paid for his last car. So twice again meaning 2 times that unknown value, whatever he paid for his last car. That means that in part B, we want to solve this equation that we just generated, 35,753.5 equals 2x minus 320.51. by first adding 320.51 to both sides, which will give us 36,074.01 is equal to 2x. Multiplying both sides by the reciprocal of that coefficient means we'll multiply both sides by 1/2, which will give us 18,037.005 is equal to x. Putting this back in the context of the problem, that tells us that he paid $18,037.01. Since money always has two decimal places, we're inferring that rounding step. So $18,037.01 for his last car. So life has been good to Franklin. He has a much nicer car this time around. And we can check that result by plugging in the value we found into our expression. So 2 times 18,037. We need to make sure we use that exact value, because again, although if we don't do that, our result will be close but not quite right. Minus 320.51 gives us the purchase price of that new vehicle. No, actually it's off. So do I have a typo in here? Yes, I am missing a 0 there. So we'll change that to 320.51. And now we see that that comes out to the purchase price that we were given in the problem. So whenever that doesn't match up, that lets us know that we made some mistake that occurred naturally, but it either could be in that check, so we want to check there, or see if in our problem solving process we made a misstep with an arithmetic step or a problem solving step.